Okay, different definitions of derivative and the derivable functions and differentiable points and non-differentiable points, everything we discussed in the first 10 points, and now we are starting differentiation. Basically, differentiation explains us the methods of finding derivatives. So first of all, here we are discussing definition method or first principles method. This definition method, the definition of derivative, already we discussed in differentiability, and now I am using that. For suppose if you wish to calculate the derivative of a function f of x, it is denoted by f dash of x or dy by dx, df of x by d of x is just defined as limit h tends to 0 f of x plus h minus f of x by h. It just represents the general form of the derivative. And for suppose if you wish to find derivative particularly at the point x is equals to a, then you need to use limit x tends to a f of x minus f of a by x minus a. Okay, see, these two are helpful to find the derivative of a function. In generally, if you wish to find, then use the first one, or if you wish to find the derivative at a particular point, you just go the second one. See, no problem. Okay, as per the requirement, as per the situation, you just move. For suppose I am giving you an example here. For suppose if you have a function y is equals to x square, and now if I wish to find the derivative of y is equals to x square at a point x is equals to a. So if I am trying to find the derivative at a point x is equals to a, then dy by dx is simply nothing but limit x tends to a f of x minus f of a divided by x minus a, and that is equals to limit x tends to a. Since the function is x square, since given y is equals to x square, treat that x square as f of x. So f of x is simply nothing but x square, and f of a is a square divided by x minus a. So x square minus a square by x minus a. You just rewrite the numerator as x minus a into x plus a. Cancel out that x minus a. You left with the limit x tends to a x plus a, and that is a plus a, which is 2a. So the derivative of y is equals to x square at x is equals to a is 2a, right? So you just memorize these two definitions. I will use as per the requirement, and for the space I am going to erase this. So now with the discussion of that example, what we have in our hands, with the discussion of that example, see, derivative of x square. So for y is equals to x square, dy by dx at x is equals to a. At x is equals to a, it is given as 2a. Derivative of y at x is equals to a is 2a. Derivative of y at x is equals to b is what? 2b. Derivative of y at x is equals to some 7 is simply nothing but 2 into 7. At x is equals to alpha is nothing but 2 alpha. So see, just observe these derivatives. Depending on the point, the value of derivative also changes. And if you observe all these points, they are in a general format, and the general form of the derivative of this y is equals to x square is 2x. See, 2x is the derivative of x square in generally, but at a particular point you need to replace x with that point. To find this general derivative directly, we need to use the first definition. Okay, see, I will give you the first definition. For suppose limit h tends to 0, that one. Okay, I am erasing this again for the space concern. Okay, just have a look. Our function is y is equals to x square, and I am trying to find the derivative of this y is equals to x square. In generally, you just use this particular one, limit h tends to 0 f of x plus h minus f of x divided by h, and that is equals to limit h tends to 0 f of x plus h is x plus h whole square. Is it right? Since the function is x square, for f of x plus h it is x plus h whole square minus x square divided by h. X plus h whole square means x square plus 2xh plus h square. Cancel out that x square and x square. then you left with what? This is equals to limit h tends to 0 2xh plus h square divided by h. So 1h from numerator, 1h from denominator gets cancelled, and you left with limit h tends to 0 2x plus h. As h is tending to 0, this answer is 2x. So in generally, for y is equals to x square, the derivative is 2x. If you wish to find the derivative at a point a, then it will become like 2a. So just as an introductory part, I explained you, see, both the ways, both different ways to find the derivative. But usually we go with this procedure, and we will find the general form of the derivatives for all different standard functions using this first principles method now. Okay, you just have a look. Yeah. Now here we are going to find the derivatives in generally for different functions, and then after that we are going to list out the derivatives for all the standard functions. Then using that list, using the formulas, we are going to extend our ideas to find the derivatives for different composite functions also. Okay, different combinations of functions also, right? The second point, to just find derivative for x power n. What is the derivative for x power n? D by dx of x power n. See, d by dx of x power n you need to calculate. That in turn explains that the function here it is x power n. So I will go for the second definition. For suppose that x is equals to a, what is the derivative? I need to calculate derivative of x power n, right? And at a point x is equals to a, I am trying to find. At a point x is equals to a, derivative is limit x tends to a f of x minus f of a divided by x minus a. That is equals to limit x tends to a, f of x is this x power n, and minus f of a is minus a power n divided by x minus a. You just have a look. Limit x tends to a, x power n minus a power n by x minus a is what? Already we learnt it as a standard limit from the concept of limits, and its limit value is n into a to the power n minus 1. Just observe it. At x is equals to a, the derivative is n into a to the power n minus 1. So if you wish to calculate derivative at b, then it becomes in terms of b, n into b power n minus 1 we will get. So if you generalize it, your answer is n into x to the power n minus 1. So this is the general form of the derivative for the function x power n. If you wish to calculate at x is equals to a, that is n into a to the power n minus 1. At x is equals to 4, n into 4 to the power n minus 1. Like that we need to mention. Okay, have a look. I am erasing this. In the same way we are going to calculate derivatives for some more standard functions. And now think about derivative of one trigonometric function, anything, okay, as your wish. Yeah, third one, d by dx of sin x. I am trying to find the derivative for sin x using this first principles method. Okay, yeah, I am trying to find the derivative for sin x using this first principles method. Okay, I am trying to calculate at a point x is equals to a. So if you wish to calculate the derivative at a point x is equals to a, or you may say at a point x is equals to alpha, that's up to you. So then at this point x is equals to a, what is the derivative? At a point x is equals to a, the derivative is limit x tends to a, f of x minus f of a divided by x minus a, and that is equals to limit x tends to a. So what is f of x? F of x is simply sin x, okay? Sin x minus what is f of a? F of a is sin a divided by x minus a. Limit x tends to a, sin x minus sin a by x minus a, that's what we need to calculate. So for the numerator it is sin x minus sin a. So sin x minus sin a means limit x tends to a, the numerator is of the format sin c minus sin d, 2 cos of c plus d by 2 x plus a by 2 into sin of x minus a by 2 divided by x minus a. Okay. And we need to calculate its limit value. Do one thing, you just send these two from numerator and write it here. Okay, no problem. This is also correct, right? Now think about it. See, just have a look at this. Now, this is sine of x minus a by 2 by sine of x minus a by 2. Something like sine theta by theta. We know its limit value is 1. So, consider it as 1. And at the end, what is your answer? So, for the space, I am going to mention here. Just have a look. So, that part is equals to cos of, as x is tending to a, replace x with a plus a by 2 into this part is 1 because sin theta by theta is 1. As a part, if you simplify, you will get cos a as your answer. Once again, at x is equals to a, your derivative of sin x is cos a. At x is equals to alpha, your derivative is cos alpha. At x is equals to any values like some beta, it is cos beta. And in generally, the derivative of sin x is cos x. Likewise, we are going to find the derivatives for all different standard functions. Okay, just have a look. Just have a look. For suppose if you wish to find the derivative for log x, one more problem. D by dx of log x to the base e. What is the derivative of d by dx of log x to the base e? So now as per the discussion, what we need to do? Okay. Its derivative is simply, directly I am going now in the general format. Limit h tends to 0, f of x plus h minus f of x divided by h. Okay, I mentioned you two formulas at the start. Okay, initially I mentioned you two different formulae to find the derivative of a standard function. Okay, and now I am going with this. Limit h tends to 0, f of x plus h minus f of x by h. How to solve this? This is equals to limit h tends to 0, f of x plus h is logarithm of x plus h to the base e, because now the function is this log x to the base e, minus f of x is log x to the base e divided by h. And in the numerator, something like log a minus log b. Log a minus log b is logarithm of a by b. So limit h tends to 0, logarithm of x plus h by x to the base e divided by h. So how to rewrite it? 1 plus h by x, right? So this is equals to limit h tends to 0, logarithm of 1 plus h by x divided by h. So we need to calculate what? The derivative. For that, you just divide with x and then multiply with x. And after rewriting that, multiplying and dividing with x, what will happen? See, just have a look. This part, logarithm of 1 plus h by x divided by h by x. Logarithm of 1 plus something by something. Its limit value is 1, right? I will show you once again. Just have a look. Yeah. Because of the space, I will show here. Okay. I will rewrite it like this. Limit h tends to 0, logarithm of 1 plus h by x to the base e divided by h. So you just divide with x and multiply with x. That's what I am saying. So after rewriting the denominator in such a way, just have a look. Logarithm of 1 plus something by something value is 1. That is a standard limit. Already we know from limits. So this is equals to 1 into 1 by x. So at the end your answer is 1 by x. So as a conclusion, we write that the derivative of log x is 1 by x. So in this case directly we are finding the derivative using this particular definition of derivative. Or otherwise at x is equals to a, you just try to find it and then generalize it like 1 by x. Okay, we have two possibilities. Have a look. So derivative of e power x by x with respect to x by first principle method. So it's a problem. Usually in board examinations you will face these type of problems. Okay. See, we will list out all the derivatives for standard functions, and then using those standard functions we will find derivatives for all non-standard functions. Actually e power x by x is not a standard function, but we have a chance to find the derivative using first principle method. First principle method is helpful, is true in finding derivatives for any function, but bit complicated. Again, to avoid that complication, to make simplifying this way of finding derivatives, we are using derivative for standard functions. Okay, so at present how to find the derivative for this? So derivative of, you just call this function as some y for some time, then dy by dx is equals to limit h tends to 0 f of x plus h minus f of x divided by h. Take this e power x by x as y and this is same as f of x. And now this is equals to limit h tends to 0 f of x plus h is what? F of x plus h means replacing x with x plus h. So this is e power x plus h by x plus h minus f of x means e power x by x, and the whole thing is divided by h. So limit h tends to 0 e power x plus h by x plus h minus e power x by x and divided by h. Yeah, what we need to do? As h is tending to 0, we need to apply limit for h, not for the other parts. So you just separate e power x and then took LCM. What will happen? Just have a look. So this is equals to limit h tends to 0. This is e power x plus h. You may write it as e power x into e power h. I am just picking out that e power x. So e power x into e power h divided by x plus h minus 1 by x divided by h. Now you just do simplification, okay, and that is equals to limit h tends to 0 e power x into e power h minus x minus h divided by x into x plus h into h. Okay, right, as h is tending to 0 we need to find out the value of this. So this is equals to limit h tends to 0 e power x by x into x plus h, and here x e power h minus x, so x into e power h minus 1 divided by h. So you just separate this e power x by x into x plus h and then separate this part first, and then give this h for these two terms and then for those two terms separately. Okay, x into e power h minus 1 by h minus h by h is 1. Yeah. Now you just have a look. As we are applying limit h tends to 0, so what will be the possible value? You just have a look. The possible value is what? See, we know as a standard limit h tends to 0 e power h minus 1 by h value is 1. This value is 1 actually. Okay. And then here if you replace x with 0, what will happen? It will become just like x only, right? So this is 1 and that is a constant 1. So here we are replacing 0, then here I will use this space. So this is equals to e power x by x into x plus 0 into x into 1 minus 1. That implies e power x into x minus 1 by x square. You just have a look. So finally the derivative of this e power x by x with respect to x by first principles method is given by x minus 1 into e power x by x square. So likewise we can find the derivatives for all the functions using first principles method. Okay, and basically we will make a list of the derivatives for the standard functions, and using that formula list we are going to find the derivatives for all the other functions with certain properties of derivatives. Everything we are going to discuss one by one. Have a look. So you just look at this derivatives of some standard functions, and we can find all these derivatives using first principles method, and using these formulas and using this list we are going to find derivatives for some other functions. Okay, and all these things we will do in the next class. Okay, for a constant function, since there is no change in its value, so its derivative is always 0. And for x power n, already we find in the second bit using first principles method, its derivative as n into x power n minus 1. For a power x log a base e, for log x it is 1 by x. For sin x derivative is cos x, for cos x it is minus sin x. For tan x is secant square x, and for secant x it is secant x into tan x. And for cosecant x it is minus cosecant x cot x, and for cot x it is minus cosecant square x. You just observe it. For cos starts with c, for cosecant start with c, for cot starts with c, we have minus signs, and for all the remaining they are the positive. Okay, and whereas these are the derivatives for the inverse trigonometry. So when you look at the derivatives for these functions, there are certain restrictions on x values also. If you say that d by dx of sin inverse x is 1 by root 1 minus x square, here for sure x value is in between minus 1 and 1. Similarly for cos inverse x also, the same restriction is applicable. Okay, and for secant inverse x and cosecant inverse x also, there is a restriction on x depending on the domain of that function. Okay, here we need to consider that mod x is greater than 1. Right, at the end these are some standard functions and its derivatives. Okay, have a look. So you need to memorize all these derivative formulae to solve different problems in the coming classes.